We'll finish up ecology by studying on the largest level, or the biosphere. So the biosphere is the area on Earth that supports life. And we do want to acknowledge that there are some living organisms that can live in pretty extreme environments. So even if we're talking at really high salinity, we have archaea bacteria that can live where it's in extremely high salinities, or extremely basic environments, or acidic environments. And so there are many places on Earth that we originally thought life couldn't be supported, but they are. However, the biosphere does stop at a certain point, meaning once you reach a certain point in the air and the pressure becomes really great, then we don't find life. Once you reach a certain part of the Earth's core and the pressure becomes so great, again, it doesn't support life. And so the biosphere really looks at where on Earth life is supported. It includes all of the living and non-living factors that affect them. And so we do want to take a moment and think back to what conditions on Earth allow for the existence of life. When we look at other planets, we do want to be able to hypothesize if life is possible. One of the big things that you are expected to know is that Earth has changed over time. And so this idea of a changing Earth is going to have an impact on species. So one of the big things that we want to know about the history of Earth is that we're looking at Earth being billions of years old and being very unstable at the beginning of Earth's history, lacking oxygen, atmospheric oxygen, or O2 oxygen. And then we do want to be able to acknowledge that at a certain point life started existing. And so we have this evolution of cells, but also of whole organisms. You are expected to know via the AP Bio curriculum about at least one extinction event. So you want to go back to your, you were allowed to choose an extinction event, and this would have been in your phylogeny unit, where you picked an extinction event and you looked at it a little bit and how it affected the rest of the organisms that were there. So you do want to make sure that you have in your little AP Bio toolbox knowing one specific extinction event and how that affected the other forms of life afterward. And so we do want to know that extinction events do happen naturally. They happen because the Earth is changing. There are things that affect Earth, like asteroids, but we also see certain periods of heating and cooling. Now this gets us a little bit into the idea of climate. Remember, climate is going to be long-term weather patterns. And so you should have a general idea of what causes long-term weather patterns, and it's really solar heat and atmospheric circulation. So we do want to remember that radiation is energy, and the main source of energy for Earth is from the sun. There are energy sources coming from the core of the Earth, but for the most part, the energy that is used by living things on Earth, that energy comes from the sun. We know that the first energy transfer is when producers fix carbon, and they take radiation, solar radiation, and they transform that energy into chemical energy, and then that chemical energy is transferred through food webs. We know that much. But we do want to know, we want to be able to make this connection that the energy source for Earth is really the sun. Short-wave radiation means that it's pretty low intensity. And so when we look at the energy spectrum and so of the electromagnetic spectrum, we should have a general idea of that energy comes in different forms, but that the most useful form for life are going to be your low intensity. You've got your visible light spectrum, and then we've got your ultraviolet and your infrared. And so you should go back to the photosynthesis unit and just take a look again at the electromagnetic spectrum. And you should be able to understand how the radiation coming from the sun affects life. But when we especially look at short wave radiation and we look at things like infrared, this is going to be your heat. And we know from the water cycle that heat is really important for the water cycle because it's going to evaporate the water, and then as that water cools, it condenses and returns to the earth as precipitation. And so that's going to have an effect on our weather and climate patterns. Another interesting thing about Earth is that the Earth is actually tilted 23.5 degrees on an axis. And so what we see here is that this is going to affect the way that radiation hits. And so this is actually what causes the seasons. And we know that the seasons are actually really important for living responses. All living organisms on Earth are going to, for the most part, experience these change in seasons, and they're going to have adaptations that allow them to respond to those changes in seasons. So you should be able to talk about at least one example of how an organism responds to changes in seasons. For example, an animal behavior that's a response to a change in season, like migration, or maybe a plant behavior or a fungi behavior. And so you should be able to talk a little bit about how seasonal changes, because if you look at this diagram, you can see that when part of the Earth is tilted away from the sun, it's going to get less heat and shortwave radiation, and that's going to make that part of the Earth cooler. And so this is why the hemispheres actually experience the seasons at different times. Because when the Earth is tilted one way, it's still rotating, it's still orbiting, but it's tilted in that direction. And so the tilt of the Earth actually has a pretty big impact on the climate that that region is experiencing. And then the other thing is really the atmospheric circulation. The rotation of the Earth, that's the spinning, not the orbiting. The spinning of the Earth will produce air currents. So we have natural air currents that are happening because the Earth is rotating. However, we are going to see that temperature and precipitation will also affect those air currents as well. So you should be able to identify some of the global patterns that produce conditions on Earth where life is existing. Just real quickly, you should be able to identify that areas of similar climate are biomes. We have terrestrial biomes and we have aquatic biomes. You should be able to talk about some of the factors that you would find in those biomes. So terrestrial biomes have similar climate, similar vegetation, and similar biodiversity. Keeping in mind that climate has to do a lot with precipitation and temperature, and that's going to affect the plant life that can live there. If you compare a desert to a tropical rainforest or a temperate rainforest, you will be able to identify that there's differences in precipitation, differences in the amount of plant life, and therefore differences in the other life forms. And so you should be able to make some predictions about this. If these areas of similar climate are biomes, we are going to be able to predict that we would see convergent evolution. So a nice tie back to the idea that if you have a similar environment, you'll see what are called analogous traits. Remember, homologous traits are when there was a common ancestor and they diverged, and though that common ancestor's traits actually underwent changes over time. So that is divergent evolution and homologous traits. That's adaptive radiation, the bicycle spoke. When we see areas that probably didn't have a common ancestor, so for example, if we're looking at these areas of the savanna, they don't necessarily, these organisms wouldn't have had a common ancestor, but a similar environment and similar selection forces. And so this is why we see the idea of wings as analogous structures. So you do need to have a general idea of what a biome is and what you can predict about life on Earth. Aquatic biomes, we should of course be able to predict that light penetration will be really important here because we need it for photosynthetic organisms. Remember, photosynthetic organisms have to be your producers. They have to be your base of your food web. And so if you're in an aquatic biome, the light has to penetrate for the most part. There are some producers that are chemoautotrophs, and they use chemical energy to form their own food. But for the most part, when in aquatic biomes, we're limited really by how deeply the light penetrates. Thermal stratification, thermal means heat. And so we are going to see that it is important that heat is able to transfer. The thermal heat from the sun is also able to transfer, and oxygen availability. These are the three main factors that affect aquatic biomes. So it's not that you have to necessarily memorize these as much as you should have something in your toolbox about a biome. So picking a biome and being able to really deeply explain the characteristics of that biome. The last part is really where we want to make sure that we have a specific tool in your toolbox. Human activity places the biosphere under stress. It is really important to know that actions of humans have drastically changed the conditions on Earth. And the one that I'm going to talk to you about the most is really global warming, but you should have a general idea of the effect of each of these human activities. So the idea of pollution, and you've been talking about pollution in your school since probably kindergarten. But we do have to be careful because there are things like trash pollution, but there's also the idea of chemical pollution. And that's where bioaccumulation and biomagnification comes into play. Bioaccumulation is the collecting of toxins in one organism. But biomagnification is the transfer of these toxins through food chains. And you might remember this through Bio 1. The interesting thing is that, remember, 10% of energy transfers, but 100% of toxins transfer. And so it's bad enough for us to spray pesticides or herbicides or even fertilizers. Those chemicals will accumulate on individual organisms. But as the food chain continues, and as a grasshopper eats grass, and as a bird eats the grasshopper, and as a snake eats the bird, we see that those toxins transfer and they actually magnify up through the food chain. And so it is really important that we understand that pollution isn't just the trash, but it's also the air pollution, the water pollution, the chemical pollution that humans have. And a lot of these human activities, remember, are just because we're not being cognizant. We're not being thoughtful about the impact that we have on the earth. We're too interested in, can I have a new pair of shoes, or can I fly to California? And all that, we're not constantly thinking about the impact that it has on Earth. Acid precipitation, you should be able to identify is a lower pH of the precipitation. And this has to do with emissions, mainly from cars and factories. And when these emissions mix with the water vapor that's in the air, they make the water actually more acidic. And then of course when they fall, they're going to affect the ecosystems that that acid rain falls on. Of course, some of the most susceptible are really going to be your aquatic ecosystems are most susceptible because that acid precipitation just really sits in those aquatic ecosystems. Deforestation, you should be able to talk a little bit about deforestation, of course, and how it affects the carbon cycle. But we do also want to be able to identify the idea of runoff and how the roots of a tree will actually hold soil in place. And so once we're cutting down the trees, we're not just removing habitat, we're not just removing food source, we're not just affecting the carbon cycle, we're also affecting the overall soil that's there and how well that soil stays in place when there's precipitation. The ozone hole, we do want to know that the ozone has a goal. The goal of ozone is O3, is to reflect ultraviolet rays. And it does turn out that there are holes in the ozone layer, and these holes are because of chemicals called chlorofluorocarbons and the fact that they destroy O3 molecules. And so we do have to identify where chlorofluorocarbons are. For the most part in the US, chlorofluorocarbons have been banned, but we do see a lot of other countries that are still using chlorofluorocarbons. The other problem with chlorofluorocarbons is they don't break down well over time. They're very stable. So one chlorofluorocarbon can actually destroy many, many ozone molecules. But the one we want to make sure that you understand the best is global warming. And global warming, this is an interesting human activity. We do want to acknowledge that the Earth does experience climate changes naturally. No one is going to argue with that. Every scientist will agree that the Earth undergoes climate change naturally. What you cannot argue with is that human activities have increased the concentration of greenhouse gases. You cannot argue with that. No other organisms are burning coal and wood and gasoline and producing things like CO2. When we look at methane as a greenhouse gas, that is produced in high amounts by humans. So as much as it might be difficult for us to admit that we're having a very negative impact on the overall biosphere, this is true. Human activities have increased the concentration of greenhouse gases. You cannot argue with that. If you burn a piece of wood or a piece of coal, it releases CO2. Humans burn fossil fuels. That CO2 and CH4 are going to trap heat. They're called greenhouse gases because when they're in the atmosphere, they trap heat. You cannot argue with that. You can do a controlled experiment, and every time greenhouse gases trap heat. Trapping heat is going to change the climate. Now, some people are against calling it global warming because really what it is overall climate change. And so it's really important that we understand that the activities that we do increase greenhouse gases. That traps more heat, and that is going to have global climate change effects. And so the last part of the notes is really looking at conservation biology and what are some of the solutions that we can do. The focus is really on conserving biodiversity. Biodiversity, you should know, are different life forms. So when we look at biodiversity, these are some of the big issues or concerns. And so when we see extinctions, we should be able to identify that they happen naturally, but also that they're going to happen because of human impact. And one of the biggest reasons for extinction is really habitat loss. Destruction of habitat, pollution of habitat, disruption of habitat, and fragmentation of habitat. I do want to just talk real quickly about fragmentation. This is the idea that, oh, if we put in a highway through a national park, we haven't actually destroyed that much of the national park. But what you've done is fragment it, so that if you have herbivores who are supposed to be grazing naturally, and they might need an acre to graze on, if you divide that acre into 2 smaller parts, that's not really a full acre for the herbivores to graze on anymore. If you saw on the news the other day the bison who were migrating up the highway in one of the national parks, that's because we fragmented their habitat. Overexploitation and invasive species. The idea with invasive species is that travel of humans has allowed species that do not normally belong there. So the introduction of foreign species. A really good example here in North Carolina is kudzu. And the problem with the foreign species is they don't experience the same limiting factors. So for example, a predator. There might not be a predator that can consume kudzu, and therefore the kudzu grows unchecked. That population outcompetes the native species. And so we do see this really big idea of, well, what is biodiversity and what are some of the ways that we can reduce human impact? That's where our notes will stop, but you need to make sure that you have in your toolbox an example of a human impact problem and a possible conservation solution.